In this video, I want to have a look at the index laws. So I want to start just by having a look at the main ones and having some really basic examples, and then we'll get onto some more complicated problems. So our first index law is all about multiplication. If we've got two terms that have the same base and they're multiplied together, then we're going to add the indices. So for example, if we had x to the 5 times x to the 3, so they both have that same base of x, because they're multiplied together, we're going to add those indices. So it's going to stay as an x, but it's going to be 5 plus 3. It's going to be to the power of 8. Division is very similar. If they've got the same base, then we're going to subtract the indices. So if we had x to the power of 10 divided by x to the power of 4, then that would end up giving us x to the power of 6. The next one is powers of powers. So if we've got a term to a power, and then that whole thing to another power, that's the same thing as that same base with those two powers multiplied together. So for example, if we had x squared to the power of 5, that's the same thing as having x to the power of 10. And our last one is the zero index. If we have anything to the power of 0, it's going to be equal to 1. So for example, if we had 2 to the power of 0, that's 1. If we had 6x, all to the power of 0, that would equal 1. So there are basic index laws. Let's have a look at the use of those in a couple of problems. So the first example we want to have a look at is if we've got 5m cubed times 4m squared. So we'd multiply our numbers together first. So the 5 times 4 would give us 20. And then our m's, we're going to add those indices because it's multiplied. So we've got a 3 plus 2 would give us 5. So we end up with 20m to the power of 5. Our second example, we've got 12d to the power of 6 divided by 4d squared. So we're going to do the numbers first. 12 divided by 4 gives us 3, and then have a look at those d's. Because they're divided, we're going to subtract the powers, and we're going to end up with 3d to the power of 4. Our third example, we've got 3p to the power of 5 squared. Now that squared, because it's outside the brackets, it's affecting everything in here, which means we need to square this 3, and we'd end up with 9. And then we're going to square this p to the power of 5, which is the same thing as multiplying those two powers together. So we'll end up with 9p to the power of 10. And our next one, we've got 25m squared n over 15mn cubed. Alright, so we're going to have to go through and simplify this one down. If we have a look at the numbers first, we've got a 25 and a 15, and we can divide them both by 5. So 25 divided by 5 just leaves us with 5. 15 divided by 5 leaves us with 3. If we have a look at the m's now, it's m squared on the top and m down the bottom. And divide those through, and we'll be left with m on the top and just a 1 on the bottom. And the n's then, if we divide through by n, we'll end up with an n squared down the bottom. So our final answer for that will be 5m left in the numerator. And in the denominator, we've got 3n squared. One last example. We've got 7p to the power of 0 plus 5. Alright, so that p to the power of 0, that's going to be equal to 1. So we've got 7 times p to the power of 0, so that simplifies to 7 times 1 plus 5, which is just 7 plus 5, which will give us a final answer of 12. So that's a few examples of how to use the index laws in problems.